Today, I am going to discuss Fehling solution and its importance. In this lesson, we are going to learn preparation of Fehling solution, reaction that occurs in Fehling solution, and role of Rochelle salt. Rochelle salt. It has been discussed in detail in the previous lesson. And finally, importance of Fehling solution. That means Fehling solution test. So let's begin. First point is preparation of Fehling solution. Let's have a look. Suppose this is a beaker with a solution. Let's consider this is solution A, in which 7% copper sulfate is present here. Another beaker where solution B is present. B solution contains 25% sodium hydroxide or potassium hydroxide and 35% Rochelle salt. That is sodium potassium tartrate tetrahydrate, which is known as Rochelle salt. Here, two solutions, solution A and solution B. When equal volumes of solution A and solution B are mixed together, then a new solution is obtained, which is actually known as Fehling solution. This solution is used to distinguish aldehydes and ketones. Fehling's test was carried out by German chemist Hermann von Fehling in the year 1849. That is why the name of the solution is Fehling solution, after its discoverer, German chemist Hermann von Fehling. Fehling solution is used to differentiate aldehydes and ketones. Now let's see what is the definition of Fehling solution. An aqueous solution of copper sulfate, sodium hydroxide and Rochelle salt, which is used to distinguish aldehydes from ketones. That solution is known as Fehling solution. Here, the mixture of A and B solution contains copper sulfate, sodium hydroxide and Rochelle salt. That is alkaline solution of Rochelle salt and copper sulfate. This mixture, this solution is known as Fehling solution. Now let's see what reactions happen in the Fehling solution. Let's move on to the next point. Reactions that occur in the Fehling solution. Let's see. Copper sulfate reacts with sodium hydroxide first. Then copper hydroxide is formed, which deposits as precipitate, and other compounds are sodium sulfate and water. So here we see that copper hydroxide is formed, which deposits as precipitate. This precipitate separates from the solution. To prevent this precipitation of copper hydroxide from the Fehling solution, Rochelle salt is used. Rochelle salt, sodium HOH HOH tetrahydrate. This Rochelle salt dissolves copper hydroxide in the solution. To form copper 2 plus ion and hydroxide ion, simply we can write it. Here, Rochelle salt acts as chelating agent that binds to copper 2 plus ion, and in this way Rochelle salt dissolves copper hydroxide in the solution. Here, role of Rochelle salt is to prevent precipitation of copper hydroxide. Rochelle salt prevents precipitation of copper hydroxide as Rochelle salt acts as chelating agent. Chelating agent, the chemical that binds to metallic ion to form complex ion. So here, this is the role of the Rochelle salt. It acts as chelating agent for copper 2 plus ion, and it dissolves copper hydroxide in the solution. Simply, we can say that Fehling solution contains copper hydroxide and sodium hydroxide. Rochelle salt keeps dissolved copper hydroxide in the solution. Now let's see importance of Fehling solution. Now the point is importance of Fehling solution, which is also called Fehling solution test. As we learned that Fehling solution is used to differentiate aldehydes from ketones. Now let's see Fehling solution test. Fehling solution, that is copper hydroxide and sodium hydroxide. Simply chemical formula of Fehling solution, which is treated with aldehydes. Suppose formaldehyde. Here Fehling solution contains copper 2 plus ion. This copper 2 plus ion acts as oxidizing agent. This copper 2 plus ion of Fehling solution oxidizes aldehyde to acid, formic acid. This formic acid turns into sodium salt of formic acid, that is sodium formate. Another byproduct is water, and finally copper 2 plus reduces to copper plus, that is cuprous oxide, which deposits as red precipitate. This red precipitate of copper oxide, that is cuprous oxide, confirms the presence of aldehyde. Let's take another aldehyde, suppose ethanol. Here Tollens reagent oxidizes aldehyde ethanol to ethanoic acid that ultimately changes to sodium salt of ethanoic acid, sodium ethanoate. Another byproduct is water, and at the same time copper 2 plus reduces to cuprous oxide. that deposits as red precipitate. If we take ketone like propanone, Tollens reagent cannot form any precipitate of copper oxide. In this way, Fehling solution differentiates aldehydes from ketones. Fehling solution doesn't give any reaction with ketones, that is no reaction or no precipitation. This is the way Fehling solution distinguishes aldehydes from ketones. Fehling solution forms red precipitate of cuprous oxide with aldehydes, but no precipitation occurs with ketones. This is Fehling's solution test, which was first carried out by Hermann von Fehling, a German chemist, in the year 1849. No more today. Thank you very much.